we draw a circle. Good. And in this circle, we draw a quadrilateral. But maybe I will require exactly same circle 3 times. Therefore, I copy, paste. Oh, that is not bad idea. They are supposed to respond to me. They are not. Anyway, okay. So I have got 3 circles and I have to draw using different colors a cyclic quadrilateral. Red, blue, green, and I am trying my level best not to have a parallelogram or a trapezium. Therefore, maybe green and last color, which should I check? Blue, violet. What is the fun in doing this? Okay. Okay. Now let me call this as A, B, C, and D. I join center. Let me use the black color for all center joining lines, that is radii. And I ended up getting one red triangle, one blue triangle, one green triangle, and one violet triangle, right? And I will have two different, I will have some diagonals also, for which I have to really choose very bad color. For one diagonal, okay, for one diagonal, let me choose this color. And for another diagonal, let me choose some very bad color. Now, suppose AB is small a, BC is small b, CD is small c, and DA is small d, and this blue diagonal is X. And whatever this color is, this diagonal is Y. Then we have a relationship here by Limits theorem. What do we have? AC plus BD is equal to X into Y. Correct? Now what we are going to do is, and the combination in anti-clockwise direction that we have here, anti-clockwise direction, the combination that we have here is blue, green, violet, red. Okay. Now, can we have some other combination? Maybe blue, violet, green, red. And can we have one more? Now, B and red are close, B and V are close, B and V. Is there any other combination that we can think of anti-clockwise out of these 4 colors?
We are BG.
BG.
BRVG. Is it going to be different? BRVG? Yes. BRVG. Okay. So let us see what we get out of this exercise. So B is B. So let me try to keep it as it is, where it is, distance wise also same. B is B, distance wise same. They are congruent segments, blue, followed by V, violet, this one, I think it is violet. Okay. I should draw that much long segment here, violet, then green, and then followed by red. So blue and red are same in this diagram. So it is going to almost look like this. And then I am supposed to draw green. And in the other diagram, blue followed by red. Red is going to look like this. V is violet, is going to violet and green. See, BRVG anti-clockwise is same as BRVG clockwise.
Yes, sir.
So it will not help us. So BRGV, BRGV, BRGV is a clockwise sense. And if
So we can
BNG, BRGV, and
do it like sub BGVR. No, sir, not BGVR. Sorry.
wait. Keep your mic off. Okay, let all of us let think, and I think there will be one more combination where blue and red are together, blue and violet are together, blue and green are together, blue and violet are together. I think BRGV is there. BRVG. Hare, bola. Try out G.
Sir, BVRG.
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 VRG. Yes. It seems BVRG is the correct combination, which is the third. So BVRG. So I need to erase this line which I have drawn. And I should draw a violet line. And then red. And then green. Okay. Now let me finish quickly the remaining part. Join with center. Did this fellow change? Okay. So what we are going to say is this is 1. This is blue is 2. Here this is 2. Then violet is 3, 4. Violet is 4. And green is 3, 3. And this is 1. Okay, now I have to draw. So if blue and red are together, the color of the diagonal is this blue, right? Therefore, this diagonal is the same as the one earlier. However, blue and violet, they were opposite to each other. Therefore, I have to have yet another color, very bad color, maybe Firangi color, let me take. Okay, this is yet another new diagonal that we have. So the first one is X and the second one is Z. Therefore, we have a relation here. Our blue segment was A, our violet segment was C, our green segment was B, and our red segment was D. So the relation that we have here is AB plus CD is equal to XZ, right, by Ptolemy's theorem. And now let us finish the diagonal business. Blue and green. Blue and green is that bad color. Yeah, bad color is this. Blue and green is this bad color, which was our Y. And blue and violet is our Ferengi color. Correct? Therefore, Ferengi is Z and this bad color is Y. Blue line is small a, violet line is small c, red is D, and green is B. Hence, by Ptolemy's theorem, we get AD plus BC is equal to YZ. It is such a simple idea of cutting the triangles of a cyclic quadrilateral and placing them inside the same circle with different orientation. You get three different algebraic identities. What is the purpose of these identities? These identities are going to provide us wonderful information. If we multiply 1 and 2 and divide it by 3, we are going to get x square is equal to AC plus BD into AB plus CD upon AD plus BC. That is how we can find out the length of one of the diagonals amongst the three if A, B, C, D are known to us. I can find out y square. How? We should multiply 1 and 3 and divide by 3. So AC plus BD into AD plus BC upon AB plus CD. This is y square. Similarly, we can find out z square by multiplying 2 and 3, dividing it by 1. So AB plus CD, AD plus BC upon AC plus BD. So this
So
is
we can find x, y, z when these three quadrilaterals are given, right? Or in one quadrilateral also we can find the diagonals.
yes, yes, you can do it in any quadrilateral. We will get an idea how to go about it in any quadrilateral. So let me take yet another circle now and take a quadrilateral here, general random quadrilateral, not parallelogram, not spatial triangle, spatial quadrilateral, nothing. Suppose this is A, B, C and D, and if I want to know the diagonal length this, okay, then suppose this length is k, then k square is equal to what? So in any general quadrilateral, if you are asked to find out the diagonal, you should be able to write down the formula of that diagonal length very quickly. Okay, so using this information over here, you write down the length of diagonal k in this diagram, A, B, C, D, or maybe I will change the problem. Let it not be A, B, C, D, let it be some other values, because otherwise you will copy. This dimension is P, Q, R and S. of the diagonal is k, what is going to be length of k? And the other diagonal is t, what is the length of t? What हो गया? Student is asking what is the guarantee that the fourth triangle, suppose from first to second, if we put 2, 4 and 3 triangles, why will first triangle go and fit properly in the remaining place? That is the question. Now, I think if you think little louder, you will get the answer. K square is going to be PQ plus RS. It is a very small space. PQ plus RS into PS plus RQ upon PR plus QS is equal to K square. And T square, PQ plus RS in the denominator, PR plus QS in the numerator, PS plus RQ in the numerator.
How to identify means what is x, what is x or z?
It is there in the diagram. You were there when we draw diagram, when we drew
Yes,
diagram?
yes,
Were
sir.
you paying attention?
Yes, sir.
Yes. So notation. I mean, this kind of I have never made in classroom also for this particular problem using so many colors. In classroom, we can use only 4 colors. Now, if you have understood this, do this again using without doing this kind of activity. But this is very, very nice, elegant. You are just cutting it into pieces and putting in the same circle, and without much algebra, without much complications, you get this desired result. Now, if I if I try to do it twice, let me check whether I can remember. Suppose I have a quadrilateral, something like this, A, B, C, D, which is cyclic, and I wish to find out the length of diagonal BD, X. Okay? So, length of diagonal BD, X is equal. Let me measure the area of triangle. This is A, this is B, this is C, and this is D. Triangle area of ABCD is equal to area of ABD plus area of BCD. Is that right? Yes.
Yes, sir.
So this ABCD is equal to, and also I can measure this area by ABC plus AC D. Now can I find out ABD? Yes, ADX upon 4R plus BCX upon 4R. Is that right? Which is equal to, suppose this is Y, ABY upon 4R plus CDY upon 4R. We have directly got the relationship that we were aiming for. Good. So what 4r is getting cancelled everywhere. X comes out to be common. X upon y is equal to, now few students will ask difficulty. X inside bracket AD plus BC is equal to y inside bracket AB plus CD. Therefore, X upon y is equal to AB plus CD upon AD plus BC. Correct? And we already know by Ptolemy, what we have? AC plus BD is equal to XY. Oh, very nice. So let us multiply XY with X upon Y. We get X square is equal to AB plus CD into AC plus BD upon AD plus. Similarly, if we take reciprocal of this, it is y upon x and then multiply with xy, you get y square, and hence algebraically also by considering areas of the same figure in two different ways, you get exactly same identity. Why is this important? Is because if I give you to construct a quadrilateral by giving four sides of the quadrilateral, if I give you only four sides, there are infinitely many quadrilaterals which can be drawn. I have to give you fifth condition. Like in triangle minimum, you have to give three conditions to create a triangle. In quadrilateral, if you want to draw quadrilateral, you require five conditions. And if I give you four sides, that is not good enough. Because suppose four sides are given to me, you can make a quadrilateral like this, and by keeping all four sides same, you can change the standard. There could be infinitely many quadrilaterals with the same four sides by changing the angles between them. And hence it is not sufficient information. You need additional condition. Either you need to give one angle between two sides, angle between small a and small b, 60 degree. Okay. Then we can fix the quadrilateral. Or you need to give diagonal AD or diagonal BD is so and so. Yes, then it is fixed. But they are the easy cases. You can very quickly sketch that quadrilateral. Amongst the difficult quadrilateral constructions, if all four sides are given, and if I say that construct a cyclic quadrilateral out of this, it is one of the difficult constructions. And therefore we need, if four sides are given, we need a formula to find out the length of one of the diagonals. This discussion that we have done so far gives us algebraically how to draw, how to find out length of one of the two diagonals. Even if we find only one, we will complete our construction. So now the question is, suppose ABCD are given, then we know x square is equal to AB plus CD into AC plus BD upon AD plus BC. Algebraically we know this, but then you are not supposed to use calculators, because in construction problem we will be given something like this: segment A is of this much length, segment B is of this much length, segment C is of this much length, and segment D is of this much length. That is what will be given to us, and using these segments geometrically, doing algebra using geometry, you need to find out the value of x. I will explain you that just now, or maybe give you some time to how do you go about finding out value of x. Okay, if given calculator, a is equal to 3, b is equal to 4, c is equal to 5, d is equal to 6, then we can substitute those values in RHS, take square root of that, our it is diagonal is ready. But if we are not allowed to use numbers, then using straight edge and compass, how are we going to estimate the length of the segment X? So we will solve this problem by algebra using geometry. I want you to think, how will you construct X out of A, B, C, D segments given to you? Maybe I will discuss it after a few minutes. Yes.
Sir, so
Let me quickly revise your algebra using geometry. First thing that we learned in algebra using geometry is add. You have been given this segment A, you have been given this segment B, and you were supposed to construct segment A plus B, which is very simple. Construct A followed by B. This is your segment A plus B. Easy. Subtraction, same as addition. No issue. Then the question came about multiplication. Understand this now. Now let me use these segments because they are colorful segments over there of quadrilateral. Suppose I want A into B. Suppose I want A into B, and then teachers must have done this experiment by selecting different unit of measures. We have shown in the class how different lengths AB we get. Say for example, if I choose half of this A, red segment A as unit, then this A is 2 and this B is 3. Therefore, the answer is going to be 6. AB, if unit of measure is equal to 1 here, then the answer will be 6. But if A entire length is supposed taken as unit of measure 1, then this is 3 by 2. And therefore, segment AB is going to be 3 by 2 and not 6. And therefore, if you keep changing the unit of measure, if suppose you take it 0.5, that means this much, then the A value is 4 and B value is 6. Then AB is equal to 24. And in multiplication, we cannot afford to get different lanes, different segments. Therefore, AB is equal to whatever you do is A into B upon 1. This is what you calculate by doing that, whatever construction you do, right? Suppose this is x1, this is y1, this is x2 and y2. So y2 upon x2 is equal to y1 upon x1. Therefore, y2 is equal to y1 x2 upon x1. So if you choose y1 is equal to a, x2 is equal to b, x1 is equal to 1, you would get ab, but it depends on what unit of measure you choose, because your x1 length is your unit of measure, and if you change unit of measure, your AB is going to change. Therefore, when do we require unit of measure and when do we not require unit of measure? This is most important question in algebra using geometry. In multiplication, we require unit of measure. If you have learned physics a bit, then let me explain you in that way. You want a segment whose length is AB. So you want length. Measure, unit of measure for this segment is going to be length. Should be equal to unit of measure for A is also length and B is also length. So if we don't use unit of measure, LHS is L, only length once, and RHS is L square, length used 2 times. They don't match, and therefore we require 1 unit length. So L square upon L matches with LHS. So this is unit balance. Wherever you have, why do we not require a unit of measure for addition? Because we want segment A plus B. A plus B is a segment whose unit of measure is L. unit of measure of A is L plus unit of measure of B is L. Therefore, RHS unit of measure is L, LHS unit of measure is L. We don't require unit of measure. Understand? The next operation to do that you have learned in algebra using geometry 3 is square root. X is equal to square root of AB. You want to find out X. And you know, complete Pythagoras, whatever you must have done. Here, do you require unit of measure? No. Why? X is a length of a segment, which should be equal to radical AB length. Radical unit of measure of A is length. Unit of measure of B is length. Therefore, it is square root of L square, which is equal to L. Yes, LHS is L, RHS is L. We don't require unit of measure. That is how you are going to go about it. Let us go back to our problem. Our problem is x square. Whatever length x is, it is a square of that. So LHS unit of measure is L square. L into L, x into x. Okay, eventually we will take square root of all of this. When we want to find out x, we will take square root of, then it will be L. Now let us look at unit of measure of RHS. L into L, that is L square plus L square. Is going to be L square. Arey, समझते कहाँ?
Yes, sir.
Plus L square is L square into L square plus L square is L square divided by L square plus L square is L square, and therefore overall unit of measure of RHS is L square. LHS L square. No need of unit of measure. Have you understood what I am trying to say? If you try to perform any algebra using geometry, if you are searching for segment, it will have unit of measure length in LHS. But if it is product of 2 or product of 3 segments, then you will require unit of measure to match the LHS unit of measure with RHS. You require 1 unit length. That is how it is. Wait. Now, so this discussion is all about whether we require unit of measure for construction or not. And this is very important. You should not take unit of measure from your pocket and start constructing segments. Complete wrong. Completely wrong. If you don't require unit of measure, all construction should happen without unit of measure, and you will believe if the segments A, B, C, D given to all students, 40 students exactly of same length A, same length B, then the quadrilateral that you are going to construct out of that is going to be congruent. All of them are going to be congruent. We don't require unit of measure, but if you solve this problem using unit of measure, no two quadrilaterals are going to be congruent. And there is, of course, unique solution for this problem. If ABCD, we are supposed to construct cyclic quadrilateral ABCD in that order, then there will be only one quadrilateral which will satisfy all these requirements. Therefore, if we want unique solution, we might as well construct a diagonal without taking unit of measure. So let me write down that x square is equal to AB plus CD into A plus BD upon AD plus BC, right? So we want x square, so eventually we want x, we don't want x square, we want x, therefore this is going to be radical of all this. Yes. Now I will call this first bracket as capital X, second bracket as capital Y, and denominator bracket as capital Z. Okay, let us see if we can get capital A. We want to construct AB plus CD. So I am going to go A inside bracket B plus CD upon A. This is my X. This is my X. Okay. Do you understand this algebra? A inside bracket B plus CD upon A. Can you do this segment? CD upon A?
Yes.
By this method, CD upon A is doable.
Yes, sir.
Therefore, we get A into B plus K, where K is CD upon A. Can you get B plus K? Yes. A into some new, let me call this as 1, that is K2. So X is going to look like A into K2. We will not be able to construct X because LHS is 1, RHS is 2 segments. So X is not doable, but still I am keeping it just like that because who knows, I will get some clue later on. Similarly, Y, if I take A common out, I get C plus BD upon A. So BD upon A, I can, of course, A common inside bracket C plus BD upon A, which is equal to A into C plus M1. I can construct M1 segment. I can add M1 to C and keep it ready for M2. Still, I cannot construct Y. Similarly, I can construct Z, capital Z, by taking A common inside bracket D plus BC upon A. I can construct BC upon A. I can name it as N1. So A into D plus N1, which is equal to A into N2. So I am left with, I am supposed to find out square root of X into Y upon Z equal to A into K2 into A into M2 upon A into N2. Square root of this. Yes. So A1A gets cancelled. 1A gets cancelled. Therefore, radical A into K2M2 upon N2. Oh, can you construct K2N2 upon N2? Yes. Therefore, A into P, this is bracket is P. Of course, we can construct A into P. And of course, we can take square root of that. That is going to be our X. This is algebra using geometry. I am sure you must not have understood, but I am keeping the entire board in front of you. Try to understand it, stretch yourself, and then if required, ask me. I will explain whatever part you have.
I have understood almost